In 1738, Swiss mathematician and physicist Daniel Bernoulli formulated a principle that relates fluid velocity to its internal pressure. The Bernoulli's principle states that the total energy in a steadily flowing fluid system is constant along the flow path. Hence, an increase in fluid speed must therefore be matched by a decrease in its pressure. Consider a pipe with a constantly moving fluid. When the fluid speed increases, its pressure drops. But when its pressure increases, the velocity decreases. Bernoulli's principle states that the total energy in a steadily flowing fluid system is constant along the flow path. Apply the law of conservation of energy. Then substitute the formulas. Divide both sides by volume or V. Or, since V is a constant, since density is equal to mass over volume, rewriting the equation, we can now rewrite the equation as one application of Bernoulli's principle is in aeronautics. The wing of an aircraft is shaped such as the upper surface is longer than the bottom surface. Hence, air has to travel further above the wing, thus having a greater velocity. Greater velocity means lesser pressure. The air beneath the wing has a lesser velocity, so it has greater pressure than the air above the wing. With a low pressure on the top of a higher pressure beneath, this pressure system creates what we call lift. The blade of the rotor of a helicopter is also shaped like an aircraft's wing, thus creating the same effect. The spoiler of racing cars has also the same shape, only reversed. The car should be stable to avoid skidding in tight turns. The spoiler is designed to create a higher pressure on its top and lower than the pressure beneath, creating what we call a down force. Another application in some spray design, when the air above the tube moves, it creates the pressure above the tube lower than the interior pressure, hence sucking the fluid up the tube. When the fluid reaches the opening, it is blown by the moving air, creating sprayed liquid. Bernoulli's principle states that the total energy in a steadily flowing fluid system is constant along the flow path. It implies that fluid pressure is inversely proportional to its velocity. Application of its principle can be seen from aeronautics to simple spray. We may not see it, and Bernoulli's principle applies to many things in our daily lives.